Let's make use of a very handy tool available in the Arduino IDE. It's called the Serial Monitor, and we can open it up as a new window, and it will monitor and display any serial communication over the USB port from our Arduino. It was nice to get direct feedback from the microcontroller, especially when we got into using the analog to digital converter. Boy, will it be useful there. But what I'm going to do is show you the experiment I told you about with my microservos. So I have the circuit used for the servo driver lesson and the very same sketch. I'm going to modify it in a few ways, and then we'll experiment with the serial monitor. I want to see what the pulse width is for every position of that servo. Now, I don't know what that number is because it's, hidden in the electronics of the microcontroller. So I'll get the Arduino to transmit the delay it's using to the serial monitor so I can get direct feedback straight from the horse's mouth. So the Arduino will tell me exactly what it's doing. So if you don't have your sketch open already, go ahead and open it up. We're going to modify it. So up here in the setup function, we're going to type in the instruction to open up the serial communication lines with serial.begin. And notice the capital S. They kind of break away from the instruction convention here, as so far all of our instructions had a small letter on the first word and the second word in the instruction was capitalized, but that's not how they did it here. Now, of course, you now know this is an asynchronous serial connection. So in order to communicate across the serial line, we need to establish things like the baud rate and agree upon that, right? So if we simply provide the baud rate, the Arduino will assume all the other defaults for you. So we put the baud rate in brackets, go with 9600, which is the most common default, and don't forget the semicolon at the end of the line. We've now established serial communication lines, so we can now send communication over the serial connection. This is done with the serial print command. Again, notice the capital S. In the brackets, we now tell it what to print. So if I put something in quotations like, I'm trapped in this computer, it will convert everything in the quotations into ASCII code, transmit it across the serial connection, and then the serial monitor will reassemble it in the other side back into the letters and numbers that you put in between the quotes. So don't forget to close the quotes, close the brackets, and put the semicolon at the end of the line. So let's open up the serial monitor, go to Tools, Serial Monitor, and this will bring up this window, and in this window is where all the action takes place. Oh, look! It's got a couple of drop-down options here, one of which is the baud rate. So what was the most important thing we needed to do when setting up a serial communication link? We had to make sure that the settings on both ends were the same, the transmitter and receiver, right? Well, the Arduino is the transmitter, and we just told it 9600 baud right here in the program. The serial monitor is the receiver, so we need to make sure this is also at 9600 baud. You'll see in a minute what happens if they're different. Just make sure they're both at 9600 for the moment. And go ahead and flash your Arduino with the new sketch. When the Arduino resets and runs its program, voila, you get the message printed on your serial monitor. So let's send another line over the serial connection. Right below the first serial print command, I put another serial, another one in quotes with something like, I don't know, just kidding, or whatever you want to put in there. Go ahead and flash your Arduino and watch what happens. It printed them both on the same line. Now, to do something about this, I can change the instruction to a serial line print by putting an LN on the end of the instruction. So serial print and serial print LN behaves exactly the same way. They both behave exactly the same way, except serial print line then throws in a couple of those ASCII control characters onto the end of whatever you send. It sends a carriage return character and a new line character. So these are ASCII codes 13 and 10. So you never actually see these, but it sure makes a world of difference when you upload your program to Arduino, which we'll do, and run it again. It puts the text onto a new line. Okay, you can leave those right there if you want. We're going to go down here to the loop function. And right at the top, I want to print out a serial line print of servo delay. So notice no quotations because this is a variable. If I put it in quotations, it'll just straight up print the words servo underscore delay into the serial monitor, and that's not what I want. What I want is to know exactly what my delay is in milliseconds, which is dictating the pulse width of going to my servo motor. Don't forget the semicolon at the end, and go ahead and flash your Arduino. Once it starts running, it'll start printing the delay on the serial monitor screen. Now it started at 1500 because that's the way we programmed it, right there. And if I push a button, that number goes up or down accordingly. I can now look at the serial monitor, look at the position of the servo horn, and see exactly what delay corresponds to what position on the servo. Now, obviously, this is very useful because if I'm designing a robot and using a servo to position its arm or something, I can now see what number does what to move the arm to a fairly precise, repeatable location. Now, another thing I can do here, which you can do, but with caution. Now, you remember I mentioned that servos can typically rotate outside of their designed parameters. Well, to find out just how far I could turn these servos, I can run an experiment. I can turn down the minimum delay down from 1000 to say 300 milliseconds. And I can alter the maximum delay from 2000 to say 4000 microseconds. Sorry, microseconds, not milliseconds. Now, my delays should try and drive the servo well beyond its normal operating range. Now, if you do this, be careful because you are going to be driving your servo motor right up against its stops, right? And especially because I have this big, powerful 6-volt pack hooked up to it, I can probably drive it so hard it'll break itself trying to get to a position where it can't go. So I'm going to be gentle and slow, moving it to the stops. I flash my Arduino, and once it resets, it'll position the servo to the middle just like I programmed it to. Now I can turn the delay down more and more until the servo won't turn anymore. Okay. That looks like it. So the absolute smallest delay I can send is about 500 microseconds. Now that's like half of 1000 microseconds. So that's actually quite a bit further. Now let's go up until we hit the other stop. Okay, that looks like it there. So it looks like the biggest number I can send out is 2390 microseconds. Again, that's quite a bit more range I can get out of the servo. Now I'm going to carefully turn this back more towards the center, just to keep from straining it. So using the serial monitor, I can find out exactly what the Arduino is doing and relate it to my designing and programming of my robot. Now, the serial monitor is running right now. What happens if the baud rate doesn't match? I'll set the serial monitor to 19,200 baud. That's the baud rate the Arduino is sending out. And what do we get? We get gibberish. The reason is because the serial monitor is going and reading a bit sent by the Arduino, which may be a 1. It goes back again in another 1/19,200th of a second. It reads again, thinking this is a next bit. But the Arduino is running at half the speed. So it's still got a 1 on the line, still the same bit. So the monitor reads another 1. The next bit in the Arduino sent was a 0, not a 1. But now the monitor reads 2 zeros. So it totally messes things up. So if you get gibberish in your serial monitor, that's the first thing you look for. Are the baud rates the same? Probably not. Okay, have some fun with that. In the next lesson, we're going to get into the analog to digital converter, and we'll use the serial monitor again to give us direct feedback on what the Arduino is actually seeing and measuring.